Good afternoon, everyone. Okay, I am Ma'am Jeneline Abamo, your OS for the subject Computing or Computer Fundamentals, which is ITE 6101 or MIS 6211. Okay, week 2, which is about the number system. So the objective for today's lesson is that we're going to introduce the number system. We're going to familiarize how to convert the number system and to determine the steps on how to convert the number system into different bases. Okay? So when you say number system class, it is a set of numbers with one or more operations that can perform like addition, subtraction, multiplication, and division. So in a number system, there are terminologies that you have to remember, like the bit and the byte. So when you say bit, it is a binary digit like the 0 and 1. And then when you say byte, okay, it is the series of 8 bits that are strung together. So there are different types of number system. The first one is the binary. So when you say binary class, it is 0 or 1. From the word bi, okay, from the word binary, which we have bi, okay, bi means 2. Okay, and next is the decimal. The decimal here is the number that we use in our daily lives, okay? From 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so that is the decimal. Okay, when you say octal class, we have 8 possibilities here from the word octal. It means 8, right? So 0, 1, 2, 3, 4, 5, 6, and 7. While for the hexadecimal class, okay, from the word hexa, hexa means 16. Okay, so the applicable values here are from 0 to 9 and then A to F. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then A, B, C, D, E, F. Okay, A is for 10, B is for 11, C is for 12, D is for D is for A is for 10, B is for 11, okay, C is for 12, D is for 13, E is for 10, 11, 12, 13, 14, and 15, okay? So that's how you convert, okay? That is the equivalent value of A, B, C, D, E, and F. Okay, so now let me show you the table 1.0 here, wherein it will show you the possibilities or the combination in different bases and what is their actual base. For the binary, we only use 0 and 1, and the base is 2. For the decimal, we have 0 to 9. Okay, it means 10 digits. Okay, that's why the base is 10. For the octal, we are using the 0 to 7. If you're going to count that, it is 8. Okay, that's why the base is 8. And then for the hexadecimal, okay, it's 0 to 9 and A to F. Okay, the base here is 16. So, we are going to study the different conversions of the number system. We're going to start with the binary. We're going to start with binary to decimal, followed by binary to octal, and then binary to hexadecimal. For the decimal, we're going to convert decimal to binary, decimal to octal, and then decimal to hexadecimal. And then right after that, we have the octal, wherein we're going to convert octal to binary, octal to decimal, and then octal to hexadecimal, okay? And then for the hexadecimal, we are going to convert hexa to binary, hexa to decimal, and hexa to octal, okay? So these are the things that we have to learn, okay, for the conversion forward, okay? So representation of the binary number. So we are using 2 for the base, okay, of the binary, okay, and then it's raised to 0, 1, 2, 3, 4, 5, 6, 7, and 8. So any number raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2, meaning to say 2 multiplied by 2 is 4. 2 raised to 3, okay, it's 2 multiplied by 2 multiplied by 2. Okay, that's how you compute for 2 raised to 3. That's why we have 8. And then 2 raised to 4, it's 2 multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 2 is 16. Okay? And then 2 raised to 5, we will have 32. Okay? And then 2 raised to 6, we will have 64. And then 2 raised to 7 is 128. And 2 raised to 8 and is 256. If you have a scientific calculator on your hands, okay, you can check it out. So moving forward, okay, Now we're going to start our conversion. Okay, we're going to start our conversion for binary to decimal. Okay, so let's we have the steps. Okay, first is plot the given number in a table following the value of number system as shown in the table 1.0. Start from number 1, then leave the other blank or put the 0 value. Add all the values from right to left at the position that are represented by 1. Then add base 2 in the final answer. Okay, so let me show this one to you. We are going to convert 10,100,11 in the decimal. And do not forget that the base of the decimal is 10. So this one, okay, the decimal digit value here came from this table. Okay, we're going to use this. Okay, the 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, and 256. Okay, that's how we arrive on this value. And then you plot your binary from right going to left. Okay, that's why we have 1, 1, 0, 0, 1, and then 0, 1. Okay, that's how you plot it. And then, of course, we are going to compute based on those binary digits are 1. For example, let's start from right to left. Okay, this one, we have 1. Okay, katapat niya 1. That's why we have 1 here. 1. So we have 1 here for the 2. So that's why we put 2 here. So these are zeros. Disregard mo yung 0. Eto, we have 1 for 16. Then copy the 16 here. This is 0. So disregard. So we have 1 for 64. That's why we have 64 here. The race, ito 0 na to. Okay. And then 0. So reject these 2. So ito na lang. We have 64, 16, and 2, and 1. So if you're going to add it up, 64 plus 16 is 80 plus 2 plus 1, it's 83. Okay, that's how you are going to convert the binary into decimal. Okay, so kindly take note that you are to put the base. The base is 10. So from 10,100,11, base of 2, the equivalent value of this for the decimal is 83. Okay. So moving forward, okay, there is another way, class. Okay, there is another way to convert, okay, the binary to decimal. Okay, all you have to do is copy the values or the digits. We have 1, 1 here. You can follow the arrow. Okay, we have 0 here, 0 here, 1, and then 0, and then 1. And then multiply by 2, and then raise to 0, 1, 2, 3, 4, 5, 6, just like what is shown on the table. So any number raised to 0 is 1, multiplied by 1, that's why it is 1. 2 raised to 1 is 2, multiplied by 1, it is 2. So this is 0, since multiplied by 0, it is 0, that's why we put 0 here. 2 raised to 4, it is 16, multiplied by 1, it is still 16. And then this one is multiplied by 0, that's why this is 0. And then this one is 2 raised to 6 is 64, multiplied by 1, we will have 64. Again, if you're going to add it up, we're going to have 83. Okay? So that's how you're going to convert binary to decimal, binary to octal. Okay? So here, if we're going to convert the binary to octal, we are to group it by 3. Okay? We're going to group it by 3, and then you can use the 1, 2, 4 for the binary. We're going to use it underneath the binary number. And then add the octal value of a number system represented by 1. Okay? So, do not forget to put the base, which is 8, and then read the final answer from right to left. Okay? So, here it is. Okay? So, for example, okay, it is the same value. We have the 10,100,11. Okay? So, now you are to read from right to left. So, group it by 3. Count 1, 2, 3. Then divide. Another, count 1, 2, 3, divide. And then 1. So, if you will notice, there's only 1 digit left, meaning to say we are lacking 2 digits. We're going to put space filler. So, our space filler is 0. So, that's why we put 2, 0 here so that we have 3 digits on this group. Okay, but this is 0. So, later on, it will be disregarded. Okay, so after that, after dividing it into groups, okay, we're going to use the 1, 2, 4. If you will notice, if you're going to add 1, 2, 4, the total of it is 7. Okay, and then of course the base is 8. That is for the octal. So 1 and 2. Okay, so to compute for this, so you get the value of 1. Okay, and then this is 1. And then another 1 for 2. So 2 plus 1, we will have 3. Okay, next. So we're done with the first group. So we do not have to get 4 here because this is 0. Okay, next on the second group, we have 0, 1, 0. So all I have to consider is the 1. The 1 is in the middle, and then if you're going to check 1, 2, 4, okay, the middle of this is 2. So we're going to put 2 here. And the next 1, 2, 4 again. And this is 1 at the start, okay? So these are 2, 0. So I'm just going to copy 1 here. That's why we have 1, 2, 3. So basically, from the binary 1, 0, 1, 0, 0, 1, 1, okay, the equivalent value of this for the octal is 1, 2, 3. Okay? So just to show to you, kapag pantay, eto siya, this is the binary, okay? So we have 1 and 2, so 1 plus 2 is 3. Ito naman, ang kapantay nito is yung 2, kaya 2. And ang kapantay niya is 1, kaya 1, 2, 3. So moving forward, so we're done with the octal, moving on to hexadecimal. So the method we use to convert the hexadecimal is that it's the same method with the octal. The only difference is that we are going to convert, group it into 4. And then we're going to use the 1, 2, 4, 8 or 8, 4, 2, 1. Okay, if you're going to total that, it's 15. Of course, the base is 16. Okay, so to do that, we're going to group it by 4, read it from right to left. So 1, 2, 3, 4. Okay, and then we have 1, 2, 3. So again, we're lacking 1 digit. Let's put a space filler. That's why we have 0 here. Okay, and then itapat-tapat mo underneath. We have 1, 2, 4, 8. 1, 2, 4, 8. Okay, now let's consider the values that the 1's value. Okay, which is this 2. So 1 and 2. Kung kapantay siya, di ba? So 1 and 2, we will have 3. This will be disregarded because it is 0. Next, we have 1, and this is 1. 2, yung kapantay nito ay 0, so disregard. And next is another 1, ang kapantay nito ay 4. So 4 plus 1 is 5. So now, read the answer from left to right. So we will have 53. Okay, therefore, the binary 10100011, okay, is equivalent to 53 base 16 or the hexadecimal 53. Okay, that's how you are going to convert it into hexa. Okay, so now we're done with the binary. Now it's the turn of the decimal for the conversion. So we're going to convert decimal to binary. So to do the conversion, all we have to do is divide. I-divide mo, you are to divide it by its base. So, if you're going to decimal to binary, ang base ng binary ay 2. So, meaning to say, divide the decimal by 2 because you are to convert it into binary. Okay? And then, after dividing it, you are to write the remainder as 0 or 1. Okay? 0 if there are no remainders. Ibig sabihin ng no remainder, walang dot, walang decimal point. But if there is a decimal point class, so automatic that is 1. Kasi bakit? Ang ina-accept naman ng binary, di ba? Either 0 or 1, walang 0.5, walang 0.2, walang 0.3. And then after that, you are to read the remainder upward from bottom to top. Okay, so now, let's do the conversion from decimal to binary. So as I have mentioned, since the base of the binary is 2, we are to divide it by 2. Our value now is 206. This is the decimal, okay? So 206 divided by 2 is 103. Are there any remainder? Wala. You put 0. 103 divided by 2, it's 51.5. So if you will notice class, there is a 0.5. Okay, so since there is a 0.5, meaning to say, may remainder. So since may remainder, you put 1. So since naglagay ka na ng 1 dito, parang wala na si 0.5 kasi you change it into 1. Okay, so you're now going to get the whole number, which is 51. So now 51 divided by 2, it is 25.5. Is there any remainder? Yes, kasi may 0.5. Yung 0.5, papalitan natin ng remainder na 1. Kasi nga, walang 0.5 na remainder sa isang binary. Kasi ang acceptable na value for the binary, it is only 0 and 1. Okay? So ngayon, ibig sabihin, wala na itong 0.5 kasi naging 1 na siya. So dito, we're going to get the whole number, which is 25. Kaya 25 yun nandito, divided by 2. 25 divided by 2 is 12.5. Is there any remainder? Yes, the 0.5. And then change it, okay, change it into 1. So that will be 12 na lang. So 12 divided by 2 is 6. Is there any remainder? Syempre, wala. It's even number. Normally, nagkakaroon lang naman tayo ng remainder kapag odd. Pag even, divisible by 2, walang remainder. So 12 divided by 2 is 6. Okay, so we do not have any remainder. So now we have 6 divided by 2. So 6 divided by 2 is 3. Any remainder? Wala, kasi even number pa rin siya. So you put 0. So 3 divided by 2. So syempre odd number na yan, di ba? So magkakaroon niya ng remainder. You put 1. Okay? So there is a 1 remainder here. Okay? 1 divided by 2. Hindi na kaya, di ba? Hindi na siya divisible. 0 point something na lang yan. So, you're going to put 1. Do not compute for that already. Okay? So, now, to read the result, the final value, we will have 1, 1, 0, 0, pataas. Mula baba, pataas. Okay? 1, 1, 0, 0, 1, 1, 1, and 0. Okay? That's how we arrive into this. Okay? That's our final answer. So, meaning to say, class, the decimal 206 is equal to 1, 1, 0, 0, 1, 1, 1, 0 of the binary. Okay? That's how you are going to convert from decimal to binary. Okay, so we're done with decimal to binary. The next is octal. It's the same class. Okay, it's the same. Kung dinivide natin si binary into 2, si octal, i-divide mo naman siya by 8. Okay? And then you are to read the value upward. So this is what will happen. Okay, so again, it's the same given. It's 206. Since we are to convert it into octal and the base of the octal is 8, we are to divide it by 8. So 206 divided by 8, we have 25.75. Now, if you will notice, there is a 0.75. So how are we going to convert that? Okay, how are we going to convert that 0.75? So to do that, first get the whole number. The whole number is 25. So lagay mo yung sa 25. I-multiply mo siya sa base. Ang base natin for the octal ay 8, kaya multiply by 8. So 25 multiply by 8 is 200. Kunin mo yung base ng number, yung 206. 206 minus the result na 200 is equals to 6. So if you convert this, ibig sabihin the remainder is 6. Okay? So now, moving for the next step, okay? Our next value is 25, okay? This is the 25. So we do not have to put the 0.75 because it is already converted into the remainder 6, okay? Now, our current value is 25. Again, you have to divide 25 by 8. 25 divided by 8 is 3.125. So then again, you have to convert the 0.125. How? Get the whole number. Ang whole number natin is 3. Multiply mo siya sa base ng octal, which is 8. So 3 multiplied by 8 is 24. Get the whole number 25. That's why we have 25 here. Minus the result, which is 24. Okay, the result is 1. So now the remainder is 1. Next, 3 divided by 8, it is not visible anymore. Kung mapapansin nyo, it's already a decimal. It's 0 point something. So kapag ganyan ang case, you do not have to do this anymore. Okay, all you have to do is get the last value, which is 3. So that's why we put 3 here. And then afterwards, you are to read the result from bottom going up. So we will have 3, 1, 6. Okay, therefore, 206 ang base of 10 is equals to 316 base of 8. So if you will notice, class, okay, there are times na hindi mo talaga mauunawaan kung Is this a decimal? Is this an octal? Okay, the only way to distinguish kung anong number system niya, you put the base. Kaya importante class, if you're going to answer, put the base. Base 10 ba siya? Base 8 ba siya? Okay, base 16 ba siya? Base 2 ba siya? Yung base 2, madaling maintindihan eh. Why? Eh kasi, puro 0 and 1 yan. Eh paano kung ganitong case? Okay, so please do not forget your bases. Okay? So now we have the decimal to hexadecimal. So this is the last conversion for the decimal. So it's the same manner. You are to divide it by the base and read the value upward. Okay? So to do that, again, we have the same given, which is 206. You just have to divide it by 16. Okay, Jetro, you are from what branch, please? So it is 206 divided by 16. Again, we divide it by 16. It's because that we are converting it into hexadecimal. Okay? Now, if you're going to divide this, the result is 12.875. Okay? So, here, again, to convert the 0.875 into the remainder, all you have to do is get the whole number, which is the 12, multiply by the base, which is 16. 12 multiplied by 16 is 192. Get the whole number from this, the base, which is 206, minus 192. Okay? Mali po to. Huwag niyo pong pansinin itong 6 na to. I think this is just a typographical error. So, 206 minus 192 is 14. Okay? And then 12 divided by 16, it is not divisible anymore. Kung mapapansin nyo, it's already 0.75. So all you have to do here is to copy 12. So meaning to say, our final answer is to, if you're going to read it, okay, from bottom going up, it's 12 and 14. But if you will recall, class, in the hexadecimal, you cannot write it as 12 and 14. You have to convert it into letter. Again, A is for 10, B is for 11, and C is for 12. That's why we have C here instead of 12. And then D is for 13, and E is for 14. Okay, 14 is E, so that's why we have C and E. Okay? So, again, do not forget the base 20610, which is the decimal, is equals to CE hexadecimal. Okay? That's how you're going to do the conversion. Okay, well, okay, so we're done with the conversion of the decimal into binary to octal and hexadecimal. So, tapos na tayo sa decimal conversion. We are now going to move on to the next, which is octal. So, of course, the octal, the base of it is 8. Okay? So there are 8 possible values here, which is 0 to 7. So for each place value, below is the value of octal to binary. The octal value from 0 to 7. Yung 0 to 7 na to, ito yung 8 possible values ng octal. Kasama si 0. Kasi yung 8 mismo, yun na yung base natin. Kaya hindi natin i-include yon. Now, if you're going to check the binary value, syempre 0, 2, 4 yan, or 4, 2, 1. 0 is 0, kaya we put 3, 0. So, dito, ginamit natin yung 4, 2, 1. Okay? Next, to get the 1, okay, to get the 1 here, use again the 4, 2, 1. So, we put 1 here kasi andito si 1, kapantay niya. 4, 2, 1, di ba? That's why we have 1 here. Again, 4, 2, 1. So, nandito sa middle kasi yung 1, kasi nandito sa middle din si 2. To get the 2 here. Next, to get the 3, 4, 2, 1. So, 2 plus 1, kaya 3. Kaya dalawang 1 to. Next, we have to get the value of 4. 4, 2, 1. Okay, so to get the 4, put the 1 here. So, 4 na kagad, satisfied na. Eh, di 0 mo na yung susunod. And then next, to get the 5, 4, 2, 1. So, we just have to get the 4 and 1. So, 4 plus 1, we have 5. So, 0 to kasi susobra na. Next, we have to get the value of 6. Okay? 4, 2, 1. So, 4 plus 2 is 6. You do not have to get this one anymore kasi lagpas na. Kasi 6 nga lang. Next, 7. So, 4, 2, 1. Lahat 1. So, 4 plus 2, 6 plus 1, 7. Okay? So, ito yung equivalent binary value nito sa octal value. So, to convert the octal to binary, you are to follow the steps below. Get the binary values of the given octal per digit. Refer to the table above for the binary value. Read the answer downward. Sample. Okay. Pwede mo naman tignan tong table na to. Okay? Pero, kung gusto mo mag-compute, madali lang din naman i-compute. Kasi yan na yung fix niya eh. Yan na yung fixed value niya. For example, number 2. Given, di ba? Ang i-convert natin is 206. Simulan muna natin dito sa 2. Asan ba si 2? Ito. Ang dapat na value ni 2 sa binary, 010. O, yan. 010. O, 0. Syempre, 0 lahat yan. O, 0. Kasi 6. Tingnan natin si 6. Okay, kung parehas. O, 110. And then 110. You just copied it. O otherwise, ilagay mo ulit. Kung hindi mo memorize yung table o wala kang pattern, lagay mo lang ulit. 421. 421. 421. That's how you just, you're going to compute for it. Okay? So, if you're going to read the result, ito naman, mula taas, pababa. Kasi it's 206. Okay? So, 206 octal. So, dito, ang 206 octal na ha, hindi na siya decimal. So, we have 010. Okay, next is tatlong 0. Followed by, dapat ito ay 110, hindi 101. Kasi magiging 5 to. Okay? So, now, it is 110. No, and then class, ito, kahit hindi nyo na isulat si 0 dito, understood na yon. Kahit idiretso nyo lang na 10, tapos tatlong 0, and then 101. Okay? That's how you're going to compute for octal to binary. Octal to decimal. Okay? For octal to decimal class, okay, you are to follow this step given the octal value, find the value of 8 to the nth power. Ito naman, multiply. Okay, multiply the given number to base 8 nth power. Add the values, multiply and add. It's multiply. Okay, convert 206 to octal base of 10. Siyempre, decimal is base of 10. So, for example, katulad nito. Okay, so we have 206 here. 6 multiply by 8. Okay, why 8? It's because it's octal, di ba? And then raise to 0, 1, 2. Tuloy-tuloy lang ang count niyan. 0 multiply by 8. 2 multiply by 8. Raise to 2. Okay, any number raised to 0, 8 raised to 0 is 1. So, 1 multiplied by 6, we have 6. 8 raised to 1 is 8. Multiply by 0, it is 0. Okay, 8 multiplied by 8, okay, 64. 64 multiplied by 2, 128. So, 128, okay, 128 plus 6, we will have 134. So, therefore, 206 base of 8 is equals to 134 base of 10. Okay, that's how you're going to compute for it. Lastly, okay, so now we have the octal to hexadecimal. It's a typographical error again, okay? So,